Welcome to this lecture on Algebra of Derivatives by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, Prince. So last time we introduced differentiable functions, right?
Yes, sir.
Yes. So today we will learn about algebra of differentiable functions. Means we will learn that the sum of two differentiable functions will be differentiable. Then product of two differentiable functions will be differentiable. Quotient of two differentiable functions where the denominator is non-zero is differentiable. So all those things we will learn today. And then also the chain rule that we apply in our differentiation, that also we will learn today, the proof of that theorem. Okay.
Yes, sir.
Okay, fine. So we are going to start with algebra of differentiable functions today. So we will just apply the algebra of limits to prove all these results. Okay, we are not going to use epsilon delta approach. We will just apply our algebra of limits theorem. So let me just give you the statement of the theorem. So the first statement is that if you have any differentiable function and if you multiply it by some scalar, then that function also is differentiable, and the derivative is nothing but the scalar multiplied by the derivative of the original function, right? So the first statement, A part, says that if you have a differentiable function, so f and g are given to be differentiable functions. So if you have a differentiable function f and if you multiply it by a scalar, then the function obtained is also differentiable, and the value of the derivative is nothing but the scalar multiplied by the derivative of the given function f. Similarly, the sum of two differentiable function is differentiable, and the derivative is given by the sum of the derivatives of the two functions f and g, right? And then product rule, in product rule, what if we have two functions which are differentiable, then their product is differentiable, and the derivative of the product is nothing but the derivative of the first function multiplied by the second function plus the derivative of the second function multiplied by the first function. Okay. And similarly we have this quotient rule. So for quotient rule, our gc should be non-zero, then the function f by g is differentiable at c, and it is given by this f by g dash c is equal to, so derivative of first function into second function, oh sorry, derivative of numerator into denominator minus numerator into derivative of denominator upon the square of the denominator. Okay. Is this screen still visible to everyone?
Yes, sir.
Okay. Yes, there was some problems. Yes, now it is fine. Okay. So A part, we will start with limit x tends to c alpha of fx minus alpha of fc upon x minus c. So somehow, so this is limit x tends to c alpha fx minus alpha fc upon x minus c. So you can take alpha common. So this is limit x tends to c alpha of fx minus fc upon x minus c. Now when you will apply algebra of limits, so you can take this scalar outside. So this is limit x tends to c fx minus fc upon x minus c. Okay, and this is nothing but alpha of f dash c. So we see that, so hence alpha f is differentiable because this limit is existing, this limit exists, so alpha f is differentiable at c, and alpha f dash c is equal to alpha times f dash c, right?
Yes, sir.
So here we have applied the algebra of limits. Algebra of limits. So here we have applied algebra of limits. Now let us go to the B part. So we have to show sum of two differential functions. So we will start with limit x tends to c f plus gx minus f plus gc upon x minus c. So this is nothing but limit x tends to c fx plus gx minus fc minus gc upon x minus c, right? And now this can be written as so fx minus fc upon x minus c plus gx minus gc upon x minus c. Now when you will use algebra of limits, so you will have this limit x tends to c fx minus fc upon x minus c plus limit x tends to c gx minus gc upon x minus c. Now since both f and c are different, f and g are differentiable, so this limit will exist and this limit will exist, and the value of limit is nothing but f dash c plus g dash c, since f and g are differentiable, and here we have used algebra of limits. Okay, so thus f plus g is differentiable at c, and f plus g dash c is equal to f dash c plus g dash c. Okay, is it clear?
Yes, sir.
Now we have to show the that the product is also differentiable at c. So again we will start with product. So limit x tends to c fgx minus fgc upon x minus c. So this is limit x tends to c fx gx minus fc gc. Now how shall we proceed, क्योंकि अब इसमें डायरेक्टली तो अलग कर नहीं सकते हम. So what we will do, yes,
So FGC or plus minus
yes, so we will एक को c रखेंगे, एक को x रखेंगे, इस तरह से कुछ भी कर सकते हो प्लस माइनस, ठीक है. So fc gx minus f plus fc gx minus fc gc. So we have added and subtracted this fc gx. So इसको मतलब fx gc भी कर सकते थे, add and subtract, बस दोनों को अलग करना है, एक को c रखना है, एक को x रखना है, इस तरह से करना है. And then and this will be upon x minus c, right? Now you can take the common outside and simplify it, so you will get this form. Limit x tends to c, इधर से gx कॉमन निकलेगा, it will become fx minus fc upon x minus c, और इधर से you will get what you will get common, fc कॉमन निकलेगा, right? Plus fc times what you will get is gx minus gc upon x minus c, right? So now you apply algebra of limit, so this will become limit x tends to c gx into limit x tends to c fx minus fc upon x minus c, plus fc is constant, so you can keep it outside, and this will become limit x tends to c gx minus gc upon x minus c, right? Using algebra of limits. Now what about this? What will be this limit?
G dash X.
No,
C.
this limit g
G
of c.
dash
Why?
C.
नहीं g dash c क्यों आएगा बेटा? Limit x tends to c
Sorry.
gx.
So G of C.
G of c. Why?
Because the G is differentiable.
So differentiable.
होगा.
So limit exists.
नहीं डिफरेंशिएबिलिटी से नहीं आता. डिफरेंशिएबिलिटी implies continuity, और continuity से ये लिमिट एग्जिस्ट करेगी. ओके,
Yes.
ठीक है. So this is your g of c. Now this limit is f dash c, क्योंकि f is differentiable, plus fc g dash c. since G is differentiable implies G is continuous at C, right? And this implies limit x tends to C gx is equal to gc. ठीक है, और बाकी लिमिट तो डेरिवेटिव से आ रहा है. यहाँ पे हमने कंटिन्यूटी यूज करी है. कंटिन्यूटी होती है तो वी कैन टेक द लिमिट इनसाइड, सो लिमिट x टेंड्स टू c इट विल बिकम gc. ठीक है, फाइन. So hence fg is differentiable at c and fg dash c is equal to fc g dash c plus f dash c gc. Okay, now last part. So we have to show quotient rule. So quotient rule में क्या शो करना है हमें कि f by g dash c is equal to f dash c by g c minus f c g dash c upon g c square. So इसमें भी फिर हमें manipulation करनी पड़ेगी. So let us try it. So consider limit. So f3x minus f by gc upon x minus c. So we have to show that this limit exists and it equals this, right? It equals this. So we will have to show this. Yes. So how to proceed for this? So first we will take, yes, fx gx minus fc gc upon x minus c. So this is limit x tends to c. When you will take the LCM, it will become fx gc minus fc gx upon gx gc and x minus c. Now can you explain why this gx we can bring it in the denominator, why we can have this in the denominator?
So 1 and 0.
Yes, why it is not 0, why this gx is not equal to 0? We are given that gc is non-zero. Why we are assuming that gx is non-zero?
Because sir, G is differentiable, that's why it will be continuous, and x not equals to 0, that's why G x will not be equals
No,
to.
no, no. See, gc is non-zero and g is continuous at c, right? Being differentiable. So this will imply that gx is non-zero for some neighborhood.
Some delta neighborhood of C.
Yes, right? For all x belonging to this, right?
Yeah.
So ये जो एक रिजल्ट जो हमने करा हुआ है इसमें क्या है, ये क्योंकि gc is non-zero, so either gc is positive or gc is negative. So in that neighborhood, either gx is greater than 0 for all x in that neighborhood, or it is less than 0. So in particular, it is not equal to 0. So ये वाला result use कर रहे हैं because we are taking the limit, so we need to work in some neighborhood of c. So we can assume that gx is non-zero because gc is non-zero. Okay, so this is very important. Okay,
Yes, sir.
fine. ठीक है, so ये याद रखना है इसको. That's why we are having this in the denominator. We can have this in the denominator. So that's why we can keep gx in the denominator. इसलिए ये defined भी है fx by gx, इसलिए we are talking about this. ठीक है ना? Okay, because gc is given to be non-zero. Okay, so now, so we have got this. Now we have to somehow bring it into the form fx minus fc upon gx minus gc. So उसके लिए क्या करना होगा हमें?
Sir, we'll add and subtract fc into gc.
Yes, या तो fc gc को ऐड एंड सब्ट्रैक्ट कर लो या fx gx को सेम, क्योंकि ये मिक्स्ड फॉर्म में है तो हमें सेम वाले ऐड एंड सब्ट्रैक्ट करने होंगे. सो लेट अस ऐड एंड सब्ट्रैक्ट fc gc, क्योंकि वो कांस्टेंट रहेगा तो हमारे आगे हमें कंटिन्यूटी और वो सब अप्लाई नहीं करनी पड़ेगी. ठीक है, सो वी विल अप्लाई ऐड एंड सब्ट्रैक्ट कांस्टेंट टर्म. सो लिमिट x टेंड्स टू c fx gc minus fc gc plus fc gc minus fc gx upon gx gc x minus c. So this can be this we can simplify it and we can get like this. This is limit x tends to c 1 by gx gc, okay, 1 by gx gc, एक तो ये आ गया, and then यहाँ से gc कॉमन निकलेगा और this will be fx minus fc upon x minus c, right? और इधर से माइनस fc कॉमन निकलेगा and it will become gx minus gc upon x minus c, right? ठीक है. So now when you will take the limit inside, use the algebra of limits. Using algebra of limits and the fact that f and g are differentiable at c, we get, so simply answer लिख देते हैं. So gx will become gc, right? So this will become gc square, right? This is gc, this will f dash c minus fc g dash c. So this is your f dash c gc minus fc g dash c upon gc square. Fine? Is it fine? So hence f by g is differentiable at c and f g dash c is equal to f dash c gc minus fc g dash c upon gc square. So this is your quotient rule. Okay, so this completes the proof of a theorem. Okay, so this is the first theorem. So it says that so this is quotient rule, then product rule, sum of two differential function is differentiable. So all these results we have done. These results तुम already use करते हुए आ रहे हो. Now you have seen the proof of them also, right? कि हम algebra of limits को inductively apply कर सकते हैं, right? Sorry, algebra of differentiation को inductively apply कर सकते हैं to show that sum of n differential function is differentiable and product of n differentiable function is differentiable, right? तो पहले वो statement दोनों ले लेते हैं. It is very important. ठीक है. So you can prove this result using induction and using the algebra of differentiation जो अभी हमने prove करा है. ठीक है. So we are not going to prove them, but you can easily write their proof. So you just need to apply induction and also just try it on your own. ठीक है. So proof can be easily proved using mathematical induction and algebra of differentiation. ठीक है. So prove it yourself. We are not going to write its proof, but they may ask you in the exam क्योंकि इसका proof book में भी नहीं दिया हुआ है. So they might ask you to prove this instead of asking to prove this algebra of differentiation. They might ask you to prove this. ठीक है. तो सब ट्राई कर लेना इसको. ये so sum of if you have n differentiable functions f1 f2 fn, then their sum is also differentiable and the derivative of the sum is given by the sum of the derivatives, right? And similarly, if you have n differentiable functions f1 f2 fn, and if you take the product of those functions, then that product is also differentiable and the differentiation of the derivative of the product is given by, so you take the derivative of the first function and multiply it with the value of the other functions at that point, and then similarly you apply this n times, okay, and add them, right? So try proving this. इसको induction से try कर लेना prove करने की. It is easy to prove, just try it yourself. अच्छा, और notations भी हैं. There are other notations for derivatives which are used in other books. So exam में अगर वो notation आ गई तो then you can other notations for derivatives. So f dash, instead of f dash, some books use df, right? ठीक है, f dash की जगह df, कैपिटल D यूज करते हैं, and some books use df by dx, right? Okay, so this is these are the sum notations. For example, if you are want to write f dash gx, so this is f dash x plus g dash x, and in some books it is written as d of f plus gx is dfx plus dgx, and in other books it is written as d by dx of f plus gx is equal to dfx by dx plus dgx by dx. So these are some of the notations that are used in other books. Yeah, so exam में अगर कोई और पेपर बना रहा है वो maybe they may use this notation. So it is simple notations. D ये तो तुमने देखा ही हुआ है कई जगह. This notation is also used at some places, right? In fact, differential equation में करा भी होगा तुमने ये वाला notation use.
Yes, sir.
Okay. Okay. Okay, so अब इसके बाद कौन सा रूल आता है? Yes,
Chain rule.
chain rule. What is that? f of g dash c क्या होना चाहिए? This should be equal to, yes, क्या होता है chain rule? f dash gc into g dash c, right? अगर तुम्हें जैसे अगर ये फंक्शन है तुम्हारे पास sin of x square, तो क्या करते हो? So fx is sin x,
पहले x स्क्वायर.
ठीक है, and gx is your x square, so this is sin x square is, अगर d by dx of sin x square करना है तो what will be this? This is, कैसे करते हो इसे? पहले तुम x square को पहले तुम sin x square को डिफरेंशिएट करोगे तो you will write cos x square, and
2x.
then you will differentiate it. So this is cos x square is, if you see, it is f dash of gx, right? And 2x is g dash x. So यही फॉर्मूला है, f dash gc into g dash c, ठीक है, right?
Yes, sir.
अब अगर हमें इसका प्रूफ करना हो तो कैसे प्रोसीड करेंगे? अगर हम इफ वी स्टार्ट विद दिस लिमिट x टेंड्स टू c f of gx minus f of gc upon x minus c, so इसमें क्या करना होगा हमें? So we can write it like this, f of gx minus f of gc upon gx minus gc into, so we are multiplying and dividing by this x minus c. So ये उस फॉर्म में आ गया क्योंकि यहाँ पे जो आर्ग्यूमेंट है वो उनका डिफरेंस ये है. So this is, अब x goes to c, g being differentiable is continuous, so gx will go to gc, right? So now x goes to c implies gx approaches to gc, so this limit can be written as, so this can be written as limit gx approaching to gc, right? f of, या y equal, अगर y equal to, this is gx is approaching to, ठीक है, या y कर सकते हो, gx equal to y भी ले सकते हो, तो ये तुम्हारा ये लिमिट आ जाएगा, right? Now this is your f dash gc and this is your G dash C, right? So this is the proof, but there is some problem in this proof. क्या है problem? Yes, what
ये
is the problem
जीरो
in
नहीं
this
होना
proof?
चाहिए।
ये जो डिनोमिनेटर है 10 डिनोमिनेटर, इसको हम जो मल्टीप्लाई एंड डिवाइड कर रहे हैं, तो दिस शुड बी नॉन जीरो, राइट? दिस शुड बी नॉन जीरो, बट अब इसकी गारंटी नहीं ले सकते हम यहाँ पे, राइट? दिस माइट क्रिएट अ प्रॉब्लम इफ इट इज जीरो, राइट? दिस माइट create a problem if this becomes zero, so we cannot apply this proof, ठीक है? क्योंकि अभी पता नहीं है, मे बी डोमेन के अंदर jx may be equal to gc in some at some point, right? we don't know about the function, so यहाँ वहाँ पे ये प्रॉब्लम कर सकता है, ठीक है? क्योंकि अगर इस तरह का फंक्शन है, इस तरह का फंक्शन है, तो it may take so many values in the neighborhood, right? अभी कुछ भी पता नहीं, अगर ये बहुत ही क्लोज ये हो रहा है तो हम ऐसा डोमेन ढूंढ ही नहीं सकते जिसमें gx is not equal to gc, right? अगर इस तरह का फंक्शन है, पीरियोडिक फंक्शन है, एंड पीरियड, ठीक है, इस तरह से बार बार हो रहा है, so we cannot, it will be very difficult to find a domain in which the value of the function is not equal to the not equal to gc, okay? It is very difficult, so उसको avoid करना है हमें somehow we have to, अब इस ये चीज डिनोमिनेटर में नहीं आना चाहिए हमारे पास, सो वी हैव टू अप्लाई सम अदर मेथड, ओके? ठीक है, वैसे तो ये प्रूफ सिंपल लग रहा था बिल्कुल, राइट? दिस प्रूफ वाज सिंपल, बट द ओनली प्रॉब्लम इन दिस प्रूफ इज दैट दिस में बिकम जीरो, दिस डिनोमिनेटर में बिकम जीरो फॉर सम फंक्शन g, और उसको हम अवॉइड भी नहीं कर सकते क्योंकि कोई ऐसे फंक्शंस होते हैं जो बहुत ही पास पास में वो करते हैं, राइट? oscillate करते हैं, so they may take value gc at so many values, so we cannot remove them, right? We cannot remove them, so उसके लिए हम we use another result which is Carathéodory theorem, okay? We will use this theorem, so we'll prove this theorem, so this theorem then we will use to prove chain rule, okay? So to avoid this situation we use Carathéodory theorem, okay? So using this theorem we can avoid this situation. We will see how we will avoid this situation, okay? To avoid above situation we use Carathéodory theorem to prove chain rule, okay? So we will see how we will we apply this Carathéodory theorem. So first we will know what is Carathéodory theorem, and then we will apply this to prove chain rule, okay? Is it clear, everyone?
Yes, sir.
This one is a wrong proof, ठीक है? इसको लिख मत देना एग्जाम में फिर. So now let us come to the Carathéodory theorem. So let me give you the statement of that theorem. So we use this theorem to prove our chain rule, so that's why this theorem has its own importance. So what it says is that if you have a function defined on an interval I which contains the point c, then f is differentiable at c if and only if, so f is differentiable at c if and only if there exists a function phi, there exists a function phi on I that is continuous at c, so there exists a continuous function phi at c, and which satisfies the property that phi x minus phi c is equal to phi x times x minus c, okay? Fx minus fc is equal to phi x times x minus c for all x belonging to I, and in this case our the value of the function phi at c is equal to f dash c, okay? So what it says is that if you have a differential function at c, then you will be able to find a function phi that is continuous at c and which satisfies this given property that fx minus fc equal to phi x times x minus c. Is it fine?
Yes, sir.
Okay, so let us try to prove this. Let us try to prove it. So first we assume that the function is differentiable at C. Okay, first we assume that suppose f is differentiable at C. So now we have to show existence of a function phi which satisfies this property. So how to define phi? Define phi from I to R as क्या डिफाइन करना चाहिए phi x इक्वल टू, बताओ
fx
C पे तो ये वैल्यू दे रखी है हमें, तो C पे तो हमें ये डिफाइन करना है x इक्वल टू C पे हमें f डैश C डिफाइन करना है, राइट, बिकॉज वी हैव टू सेटिस्फाई दिस प्रॉपर्टी. सो ये हमें दिया हुआ है यहाँ पे हिंट. अगर x नॉट इक्वल टू C है तो क्या डिफाइन करेंगे हम?
fx minus c upon x
यहाँ पे देखो
minus c.
यस यहाँ पे हमें दे ही रखा है, राइट. यहाँ पे phi x क्या दे रखा है हमें? fx माइनस एफ सी अपॉन एक्स माइनस सी. हमें डिफाइन करने का आइडिया दे ही रखा है इन्होंने. यहाँ पे दे रखा है कि C पे हमारा f डैश c होना चाहिए एंड एट ऑल अदर पॉइंट्स phi x should be equal to fx minus fc upon x minus c. So you can take this hint from here only. So phi जो है हमारा ये होना चाहिए, राइट. So we can define. So बस अब हमारा aim क्या हो गया? तो phi तो definitely it satisfies these two properties, right. So only aim is to show that it is continuous at C. So बस हमें ये show करना है that it is continuous at C, क्योंकि ये चीज़ तो by definition ही हो गई हमारी, ये चीज़ भी by definition ही हो गई, हमने यहीं से hint ले लिया, ठीक है. So we are only left to prove that phi is continuous at C, right. उसके लिए क्या करना होगा हमें?
लिमिट सर,
लिमिट शो करना होगा. क्लेम phi is continuous at C. So for that we will take limit x tends to C phi x. So this will be limit x tends to C fx minus fc upon x minus c, right, which is equal to, so what will be this limit? This is f
f
dash
dash
c.
c
Why? Because f is
is
differentiable
differentiable
at C, so which is equal to our phi of C. हमने इसको phi of C का है. So hence phi is continuous at C. Okay, so we are able to show the existence of function. So one way we have proved, if and only if one way we have proved, we have assumed that f is differentiable at C, and we are able to find a function phi that is continuous at C and it satisfies these two property, right? Yes. Hence phi is the desired function. Okay. Conversely, assume that there exists a function phi which is continuous at C and which satisfies fx minus fc equal to phi x times x minus c for all x belonging to I. Claim f is differentiable at C and f dash c is equal to phi c. So हमें ये शो करना है, ठीक है. So f is differentiable at C के लिए क्या करना होगा हमें? We will have to start with limit x tends to C fx minus fc upon x minus c. So this is your limit x tends to C. So using this property, it is phi x times x minus c upon x minus c. So this is limit x tends to C phi x, right? And what will be this limit?
phi c,
Phi c. Why? Because
because
Continuous.
phi is continuous at C. So this, so hence, so we are able to show that this limit exists, और जब भी limit exist करता है, so that means our function is differentiable. Hence f is differentiable at C and f dash c is equal to phi c. hence proof. So we have shown both the sides. Simple proof था, कुछ भी नहीं था. One side तो यहीं से definition से आ जाता है, दूसरी side भी by trivially आ जाता है. ठीक है, so there is nothing in this proof, right? Easy proof. Is it clear? The proof is clear to everyone? Yes?
Yes, sir.
Okay, so we started with the, so first हमने assume करा था f is differentiable and then we defined this function phi और वो satisfy करता है ये property. और conversely हमारे पास phi एक ऐसा function है, we have to show this. So बस हमने ये property use कर ली अपने आप ही यहाँ पे. ठीक है? So there is nothing in this proof, nothing tricky in this proof. So now we come to our chain rule. Okay, first let us do an example for this. So example के एक function phi ढूंढ के दिखाते हैं. Let fx equal to x cube for all x in R. Okay. For and let C belong to R be any point, and let C belong to R be any point. Find a function phi defined on R that satisfies the Carathéodory theorem at point C. So कोई फंक्शन बताओ phi क्या होना चाहिए हमारा C के पास? Yes? fx is this x cube. You have to find a function phi. So phi क्या होना चाहिए? Phi should satisfy. Phi क्या define करा हमने देखो. Phi should be this function fx minus fc upon x minus c. This should be the function, right? It should be f dash c at c, and it should be fx minus fc upon x minus c. This should be the this is the formula for phi. So phi x को define करने के लिए पहले हमें f dash c निकालना पड़ेगा, right? F dash c is 3c square, right? We know that f is differentiable at c and f, या इसको ये ना भी करो, so you can have this. So define phi from R to R as phi x equal to fx minus fc upon x minus c if x is not equal to c, and it is 3c square if x is equal to c. ठीक है, ये हमें पता है by our knowledge. So this is equal to x cube minus c cube upon x minus c when x is not equal to c, and 3c square when x is equal to c. So this is your, ये क्या आएगा? x square plus cx plus c cube, and it is 3c square, sorry, c square.
सर सी स्क्वायर आएगा.
Yes, yes. So this is right. So this is your desired function phi. So the above function phi is the desired function. It is continuous at c also. You can see यहाँ से भी c cube भी आ रहा है जब लिमिट लोगे, और ये 3c square है, ठीक है? Is the desired function. Okay, so this is how you can find the function phi. Sometimes they might ask you to find the function phi, so just use this formula. Phi x should be equal to this. यहाँ पे ये f dash c होना चाहिए जो भी function phi, ठीक है? Is it fine? Is it fine everyone?
यस सर.
Yes. Now let us come to the chain rule. Now we are going to prove the chain rule. So we are given two functions. We are given g from I to r and f from this is g, this is your interval j, this is your interval I, and this is your function r, and this is the okay. You are given that this is your fj, okay. F of j, this is the function f, this is the function g. So this will be the function. What will be this function? Yes, what will be this function? G of f, right? Yes, this is a j, f is going from j to r, okay. Lekin fj is contained in I, so that means it is a function from j to I basically, and fj, g is a function from I to r, fj is contained in I, fj is contained in I. So all these things are given. You are given f is differentiable and c is here, c is some point here, and your so fc will be somewhere here, this is your fc, okay. This is fine. So c is here, fc is here, somewhere here, and so you're given that f is differentiable at c, f is differentiable at c, and g is differentiable at fc, right? Then you have to show that g of f is differentiable at c, okay, and the value of the derivative is equal to this. Fine. So we will use Carathéodory theorem to prove this. So given f is differentiable at c, g is differentiable at fc, to show g of f is differentiable at c, okay. So this is what we have to show, and g of f dash c is equal to g dash fc into f dash c, right? Is it right? So how we should start? So पहले f की differentiability use करेंगे. So since f is differentiable at c, so there exists a function, ठीक है, by Carathéodory theorem लिख देते हैं, by Carathéodory theorem there exists a function phi from j to r such that three things will hold, right? Three things are there, such that first, phi is continuous at c, second, fx minus fc equal to phi x times x minus c for all x in j, right? And third, phi c is equal to f dash c, right? Yes, यही होती है Carathéodory theorem, that there will exist a function phi from j to r domain of f such that phi is continuous at c, fx minus fc equal to phi x times x minus c, for all x belonging to J, and f phi c should be equal to f dash c, right? Yes, is it right? Yes,
Yes, sir.
everyone.
Yes, sir.
Okay, fine. Again, as G is differentiable at FC, so by अब क्या होगा इससे कैराथेओडोरी थ्योरम से? Yes, there exists a function psi from I to R, domain of F, right? Such that three things will hold. First, psi is continuous at FC. Second, gy minus g of fc is equal to psi y minus fc, right? And third, psi of fc is equal to g dash fc. Fine, is it right? सो एफ और जी के एफ डिफरेंशिएबल था तो उसके कॉरेस्पॉन्डिंग कैराथेओडोरी थ्योरम से एक फंक्शन आ गया फाई विच सेटिस्फाइज दिस प्रॉपर्टी. अगेन नाउ जी इज डिफरेंशिएबल, सो उसके कॉरेस्पॉन्डिंग कैराथेओडोरी थ्योरम से एक फंक्शन आ गया साई विच सेटिस्फाइज दिस थ्री प्रॉपर्टीज. अब हमें इस पे अप्लाई करना है. अब जी एफ की कॉरेस्पॉन्डिंग हमें एक फंक्शन ढूंढना है जो कि ये तीन प्रॉपर्टी सेटिस्फाई करे. सो वो कौन सा फंक्शन लेंगे हम? GF के corresponding yes,
So phi and psi का composition.
yes, psi of phi, right? देखो कैराथेओडोरी थ्योरम अप्लाई करनी है ना, तो हमें क्योंकि GF को डिफरेंशिएबल शो करना है, we have to show GF is differentiable. So GF को डिफरेंशिएबल शो करने के लिए क्या करेंगे? We will find some function with in the domain of GF such that it satisfies the three properties, right? So वही सेम वो क्या ले लेंगे हम? psi of phi. Now इसको डायग्राम भी बना लेते हैं जल्दी से इसका, so that we can easily have this. So this is your R, this is your I, this is your J, this is your psi, this is your phi, this will be your psi of phi. ठीक है, right? Now since composition of two continuous function, right, we have done this result. Two continuous function is continuous, so psi of phi is continuous at C, right? ठीक है, so psi of phi is continuous at C because psi is continuous at FC, phi is continuous at C, so psi of phi will be continuous at C, right? ठीक है, is it fine? Is it fine?
Yes, sir.
Okay,
सर एक बार
तो
पेज
हमने
नीचे कर
एक
सकते हैं?
हाँ so हमने एक प्रॉपर्टी तो शो कर दिया है कि that psi of phi is continuous, ये वाली प्रॉपर्टी शो कर दी है. now we have to show this property, so इसके लिए क्या करेंगे? again we will start with psi of phi. so हमें यही शो करना होगा, GOF x minus GOF c, उससे स्टार्ट करना होगा, and we will try to find it and show that it is equal to psi of phi x into x minus c. So consider G for all x belonging to For all x belonging to J, consider g of x minus g of c. So what this is g of fx minus g of fc. So what will be this? ये क्या हो जाएगा? जिस ये वाली प्रॉपर्टी अप्लाई करेंगे तो it will be yes psi of fx into fx minus fc, right? Right, g of y minus g of fc is equal to psi of this minus, right, y की जगह fx है, is it right? अब fx minus fc को क्या लिख सकते हैं? This is psi of fx into fx minus fc को phi x times x minus c. Okay, so instead of psi of phi हमें ये फंक्शन लेना पड़ेगा, प्रोडक्ट ऑफ psi of f into this. ठीक है, कॉम्पोजिशन नहीं लेना पड़ेगा क्योंकि दिस इज, so we will have to, क्योंकि it is coming out to be this function, right? It is coming out to be this function psi of f dot phi x into x minus c. So we will have to take this function as a new function. psi of phi नहीं लेना पड़ेगा हमें, ठीक है, ये this will not work, right? So we will have to take this. Because we will have to take this function. Is it fine? So this function will work. Psi of phi नहीं लेना पड़ेगा हमें, psi of f dot वो लेना पड़ेगा product, because we will have to take this function also. There is another function from this f, so we will have to take psi of phi dot phi. This function we will have to take. ठीक है? Is it fine? Are you getting my point? Yes, because हमारे पास यहाँ पे ये function आ रहा है, so we will have to take this function. Okay, so now let chi equal to psi of f dot phi. Now since composition of two function is continuous and also product of two continuous function is continuous, it follows that chi equal to psi of f dot phi is continuous at C, because your phi is continuous at C, f is continuous at C, and psi is continuous at fc. So psi of f will be continuous at C and phi is also continuous at C, so this product will be continuous at C, right? Is it clear? Is it clear everyone?
Yes, sir.
So हमें ये फंक्शन लेना पड़ेगा, psi of phi नहीं लेना पड़ेगा, we will have to take this particular function. So this ये chi हो गया. So अब दो प्रॉपर्टी तो हमने सेटिस्फाई कर दी, राइट? अब थर्ड प्रॉपर्टी शो करनी है हमें, that chi of c should be equal to, क्या होना चाहिए वैल्यू इसकी?
G dash fc into G dash.
Yes. Now look, consider chi of c. So this is limit x tends to c chi of x. So this is limit x tends to c, phi of x क्या है, psi of f dot phi x. So this is limit x tends to c, psi of fx dot phi x. So this is, because these are all continuous at c, psi of fc into phi c. So this is psi of fc dot psi of fc dot phi c, राइट. यहाँ पे लिमिट तो लेने की जरूरत ही नहीं थी क्योंकि हमने डिफाइन ही ऐसे कर रखा था. सॉरी, इतना करने की जरूरत नहीं है, इसको डायरेक्टली लिख सकते हैं. कंसीडर chi of c which is equal to psi of fc dot phi c. ठीक है, so this is psi of fc dot phi c. Now psi of fc is from this g dash fc, right? This is g dash fc and this is f dash c. So thus now, so we are able to, so chi is a function, it satisfies the three properties of Carathéodory theorem, right? Yes.
Yes, sir.
So thus chi is a function that satisfies the three properties of Carathéodory theorem. So by Carathéodory theorem, we have GOF is differentiable at C and GOF dash C is equal to chi of C, which is equal to G dash FC into F dash. Okay, is it fine? Is it fine, everyone?
Yes,
Yes,
sir.
sir.
Hence the proof. Okay, so this is how you can prove the chain rule. Okay, so we are already above time, 10 minutes over time. So let us end this class. Okay. Okay, so bye everyone. Have a good day.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.